This is the week 15-16 homework, problem number 2, just to kind of get you started on this stuff. So we've got a data set. They've sampled 8 bears. They measured the distance around the bear's chest and weighed the bears. Right. The correlation coefficient was determined to be R equals 0.895, and we wanted to use a significance level of 5.05% to determine if there is a linear correlation. Alright, so remember, sample size is 8. Alright, so that means that N is 8 here. So we're down here at 8, and we want to use a 0.05 level. Alright, so that's 0.707. Okay, so R is bigger than 0.707, so that means we do have a linear correlation. So it's either going to be A or C. Yes, because the absolute value of the test statistic, which is R, exceeds the critical value. So that's our answer. Right. The other one that said yes says because the test statistic falls between the critical values. Right. That's definitely not it. Right. The critical value, we compare the absolute value, whether this is positive or negative. We compare that to the critical value. So A is our answer. Alright, what proportion of the variation in weight can be explained by the linear relationship between weight and chest size? Alright, remember that's R squared. Alright, R squared gives you the proportion of variation that can be explained. Alright, so take your R value, which is 0.895, and square that value. So 0.895 squared gives us 0.801025. Alright, they want it to 3 decimal places, so 0.801. Alright, 3. The heights in inches of the pulse rates in beats per minute for a sample of 10 women are measured, and with technology, the paired heights pulse data, the linear correlation coefficient R is found to be 0.69. Is there sufficient evidence to support the claim that there is a linear correlation between heights and pulse rates? Alright, they want us to use an alpha 0.05. Alright, sample of 10 women, so that means N is equal to 10. Alright, and they want us to use 0.05. So that would be 0.632. So 0.69 is greater than the critical value 0.632, so there is sufficient evidence to support the claim. Alright, the R value is greater than that cutoff number, so that means that we do have evidence to suggest that there is a linear relationship here. Alright, we want to find the correlation value. Alright, now if you were to click on help me solve this or view an example, they're going to have you go through all of this nasty formula and go through and do all that stuff. Okay, don't do that. Okay, don't ever do that. Go to your list editor, and if you got numbers in here, remember you can clear it out by highlighting the name of the list and press clear and then enter. Alright, and then highlight the name of the other list, press clear and enter. We do need 2 lists because we're going to put in one into L1 and one into L2. So we're going to put the budget in our first list, and we're going to put the gross in our second list. Alright, so just enter in your data. And then once you get all your X's in, go back and put all your Y's in. And then once you've got that data in there, you're going to press the stat button again, just like you did to get into this menu. You're going to press stat to run the linear regression. Okay, so all our data's in. We're going to press stat, and we're going to come over to calculate. Alright, now there's the one variable stats that we've used already this semester. There's what we want, linear regression AX plus B. So come down, highlight that, and press enter. Now if yours is like mine and it's not bringing up R, if the R value is not coming up, then that means your diagnostics is not turned on. Alright, so to turn your diagnostics on, alright, here's your catalog menu. You want to press second catalog. Alright, and notice how it's in alpha mode, meaning that the letters are highlighted. So come down here to find D and then scroll down until you see diagnostic on. Alright, you want on, don't go to off, diagnostic on. Tell it to turn on, and now run your linear regression again. And now it has R displayed. Okay, so R to 3 decimal places is 0.926. Alright, find the critical value of R from the table showing the critical value for Pearson's correlation coefficient using 0.05. Alright, same thing we've been doing. There are 1, 2, 3, 4, 5, 6, 7 values here. So now N is 7. So we got 0.754. Alright, now again, R is bigger than that, so we do have evidence to conclude we have a linear correlation. Alright, and it's because the absolute value of the correlation coefficient is greater. Right, the absolute value of R is greater than that number we got from the table. Right, that's what you're always checking for when you come up with that number from the table. Is R bigger than that, or is the absolute value smaller than that? Alright, same thing with number 5. Clear this out. Go in, edit this. Always clear it out because you may have more values underneath the bottom of the screen, below it, and you just want to make sure that you don't have anything in there. Alright, so 115, 95, don't mix and match, just make sure you go straight across your X's and then go down to the Y's. And check your data, make sure you're putting it in there correctly as you go. Alright, same thing as before. Stat, as soon as you turn that diagnostics on, it'll be on every time. It doesn't turn off until you turn it back off. Alright, so this time we got an R value of 0.169 to 3 decimal places. And now they want to find the critical value from the table. Alright, so we got 1, 2, 3, 4, 5, 6, 7, 8 numbers. So we come down to R is 8. So we need the 0.707. Alright, now this time R is smaller than 0.707. So is there sufficient evidence? No, because the absolute value of the correlation coefficient, R is the correlation coefficient, is less than the critical value. So that's when we don't have enough evidence to say there's a linear relationship. Alright, same thing we've been doing. Plug in your numbers. Stat. Clear out both your data sets, and then just enter them in. And notice that this rounds it but it doesn't round it as far as computing R and everything. It still has all 3 decimal places that I'm putting in there. It's just rounding it on your screen, so it's all still there. Alright, same thing. Stat, remember it's underneath calculate, and then we want to do linear regression. Alright, there's our R, 0.593 to 3 places. Alright, from the table we got 1, 2, 3, 4, 5, 6, 7, 8. 0.707, just like last time. Alright, R is less, so the absolute value of correlation coefficient is less than the critical value, so there's no linear correlation coefficient according to our 0.05 level. Alright, so that's the basics of these. Alright, does it appear that winning times are affected by temperature? No, because there is no linear correlation between the variables. If that's all our only 2 choices, then that's what we would conclude. Alright, so there's the basics of it. Most of these at the beginning are just like this.